enough of Hello World. Let's now do some real stuff with SDL. I will first declare this input event SDL quit. So the input keyword declares events from the environment. SDL has many events for mouse, keyboard, joystick, and etc. SDL quit is an event that is issued whenever I press the close window button in the window, or I press Alt F4 to close the application. I want to create my window, so SDL provides the SDL window type that we use with pointers. To create the window, I have to call this function SDL create window. I need to pass the name of the window, the size, the position, and the size of the window. After I create, I want to await the SDL quit, and finally return to the operating system. If I try to compile this code, I'll get some errors. First, I need to declare this type that I'm using. So, as I do with functions, I also have to do with types. For types, I need to say the size of the type, but we are using only pointers to this type. So we can leave the size of to 0, and we are saying that we are not instantiating this type. We only use this as an opaque pointer. Now I have to declare the function SDL create window, and now is the point that I want to show. In line 8, it is complaining that the attribution requires finalize. So this attribution here to the win variable when I call this function here. The problem is that this function is returning a pointer, basically from nowhere. So this function has a side effect. In this case, the side effect is that it is allocating memory under the hood. So cell just expects that you write a finalizer for this code. I will explain briefly, but let me just advance now. So I have the finalizer here is to destroy the window, and it now complains about the destroy function. I have to declare here destroy, and now on line 13 it also expects a finalizer. In this case, I'm passing a pointer to a global function, and cell doesn't know anything about this function. Maybe this function will hold this pointer for a while and my variable goes out of scope and it will hold a dangling pointer there. So, but in this case, this call is safe because this function does not hold this pointer. It is actually deallocating the memory. So we can put an annotation here to tell the compiler that this function does not hold pointers passed to it. And now it compiles. And I can execute here. So I'm not printing anything on the window, not drawing anything, but it should answer to this click, and it terminates the application when I clicked there. Let's go back to the finalizer here. So first, this executes as soon as it is reached. So the program starts, these are only declarations, so it will create the window. But this code, it is only registered as a finalizer. It's not executing now. I'm not destroying this window just as I create it. In fact, the finalizer is for this variable. When this variable goes out of scope, that this clause here will execute. But this variable is in the top level of the file. So it means that this finalizer will only execute when I return, or just before I return to the operating system. So I will execute, create the window, then I'm only registering this, then I await the SDL quit, and the program suspends. And you see that nothing else happens, it's just expecting this event. When I click the X in the window, this event is triggered, the program resumes, and before returning, it now will execute this code to free the memory for the window. So the finalizer is good because first, it enforces that I properly handle this allocation, but also it keeps both the allocation and the allocation close together. It's easier to follow. Let's draw something on screen. I need a renderer for this, SDL Renderer. Then I need to create the renderer, SDL create renderer. I need to pass the window and some other parameters here, and it will also complain about undeclared types and everything. Of course, I already have all these types and constants and functions declared in another file, because this is related to SDL and never changed. So it just needs to include here this file, and I can remove these declarations from here, but it still complains about the finalize in line 16. So the renderer also is allocated on the heap, so I need to destroy it. Destroy. Now it should compile. SDL destroy renderer. Okay. Now we declare a rectangle to draw on screen. Rectangle R. So the width 100, the height is 100, the position in X and Y. And then there is another event that SDL calls whenever I want to redraw the screen. I need to declare it here. And when this event is called, I will call this function that sets the color to draw for my renderer. I will choose white. Then I want to fill a rectangle. I have to pass a pointer to it. And finally, I present the renderer here. Render, draw color. And now I have my rectangle, and I'm still, after I redraw, I'm still awaiting here the quit. So I have to press here the quit and the program terminates. It happens now that I have two finalizers in my code, and both finalizers are referring to variables in the same scope. So how do they execute? The rule for finalizer is the first finalizer registered is the last one to execute. So in this case, when the program terminates here, it will first free the renderer and then the window. That's exactly what you want, because the renderer depends on the window, as you can see here. Let's do some animation with this rectangle. So, in parallel with the program, I will write a loop that every 20 milliseconds I want to increment my position forever. So now my position is varying, so I need to redraw the screen continuously. So this needs to be in a loop in parallel with the increment, and as well I want to terminate the application at any point. So whenever I quit, I want to kill both trails and return to the operating system. Let's start from the beginning of the screen here, and let's see. It works, but we are not clearing the screen for every redrawing. So what we redraw here will stay forever. We need then to create another rectangle for the background, e.g. so the size of the screen starting from 0. Here we need to also set the color to black and pass the background. Now it should work. Here is long. Okay, now it's worked as I wanted, but it goes out of screen. So now let's do a bouncing animation. So instead of looping forever, I want to loop 500, so it will increment 500 pixels, Then I want the same behavior but going back. And also I want all this bouncing to run forever. So I will surround everything with another loop, and let's see if it works. So it will advance 500 pixels and then go back 500 pixels, and we will stay in this loop forever. So here you see that when this loop terminates after 500 iterations, I go back in 500 iterations and I repeat this forever. So this runs forever. The redrawing trail also runs forever. So the only way to quit the application is by pressing the X button here. I now want to include another rectangle on screen. So let's simplify again the behavior for the rectangle. Just want to move 500 pixels and hang there forever. Let's run a little bit faster and put this higher. Let's see. Okay, 500 pixels and it stays there. So the await forever. Forever is a reserved keyword in cell and represents an event that never occurs. So after this loop terminates, we just hang on this trail here. This trail never terminates. I want to add another rectangle. Let's add a similar code as well, and also the redrawing here. And now let's call it S. This is okay, and this. This one I will run even faster, and I need to put it a little bit below the other. Let's see. Now you see this one moves twice as fast as the other one.